All right, thank you for joining us today. And in this video, we are going to practice using Leibniz theorem. We've learned a lot, and we've learned how we can apply the formulas. Right? We know the formula, we know the tips. So now let's look at this. Now, the first thing I need to check was the order. This is not telling us to go to the nth derivative, but to the third derivative. It means that, as I was saying, Leibniz theorem is actually a product rule. So this is a product rule, but we need to do the product rule how many times? 3 times, which is going to be a lot. So for example, if I'm using product rule, then let me assume that what is here is y, then I'm going to have y is equal to x squared e to the power x, right? So product rule, my a is equal to x squared, my b is equal to ex. A prime is equal to 2x, b prime is equal to still ex. So the first derivative will be equal to multiply this by this, multiply this by that. So I'm going to have x squared ex plus 2x ex. So you see, I'm done with the first derivative. I'm going to the third derivative, right? I need to do the second one. And I have product rule here. I have another product rule here. So the next thing that I need to do is I need to do the product rule again, but I'll go straight. So the first one is going to be x squared ex plus 2x ex plus, then I'll do this one. That one is going to give us 2ex plus, then when I differentiate this one, I'm going to have 2ex, right? So I can simplify the function small. X squared ex plus 4x ex plus 2ex. Then this is a second derivative, right? This is a second derivative. Then I need to go to the third one. So the third one, I do it again. X squared ex plus 2x ex plus 4x ex plus 4ex plus 2ex. So this is going to give us, when I simplify this, I'm going to have x squared ex, right? And then plus 6x ex plus 6ex. So this is what I'm going to have with the product rule. So I need to do product rule. So imagine I'm doing this to the nth term. I'm going to do a lot of product rule. I'm going to do a lot. So here is where we are going to use Leibniz theorem to work out and even see if we are going to get the same results, right? So now here, as I said, I pick my y to be equal to x squared ex. So what I'm going to do is I need to pick my u, I need to pick my what? Vin, because this is equal to u vin, right? So my u is the one that I can differentiate to a constant term. So here I'll pick u to be equal to x squared and vin to be equal to what? E to the power x. I forgot to write the formula first. When you write the formula, it helps you to know what you are going to do. So the nth derivative is n combination 0, u0 vin n plus n combination 1, u1 vin n minus 1 plus n combination n un vin 0. Remember, we said vin 0 is the same as vin, and then u0 is the same as u, right? So now what we just need to do is we need the third derivative. So this one, we are going to differentiate this one to the third term, this one to the same thing. So I'm going to have u, right, 1, which is going to be 2x, u2, which is going to be, u2 is going to be 2. And when I go to u3, what happens? Guess what happens at u3? When I get to u3, this one gets to 0. Because when I differentiate it to the third term, I get it 0, right? And then this one is vn1. When I differentiate e to the power x, I still get e to the power x. I still get e to the power x. So I can generate the nth derivative. It implies that when I differentiate this one to the nth term, so I'm going to get it to be that way, right? So now the next thing to do is, now that I have this information and this information, I'm going to plug them in the my Leibniz formula. So I'm going to have n combination 0. Now we said u0 is the same as u. So I'm going to have x squared times, now what is vein n? Vein n is this. So I'm going to have ex, right? Plus n combination 1 right here. What is u1? u1 is 2x. So I'm having 2x. Now what will be vein n minus 1? Since all of them are the same, then it means that vein n minus 1 will also going to give us ex. Then plus 2, plus n plus n combination 2. Now n combination 2 will go with u2. u2 is 2. So I'm going to have 2 times the same, and then with this one too will go with vein n minus 2. Vein n minus 2 is still the same thing, so I'll pick it like this way, right? And I have it this way. Now when I want to move again, since this one is 0, everything goes to 0. So this is where I'm going to stop. Now remember that we did n combination 0 and we had 1. We did n combination 1 and we had n. And we did n combination 2 and we had n minus 1 divided by 2, right? You can also verify. Remember that n combination k is equal to n factorial divided by k factorial n minus k factorial, right? So you can verify that. So it means that this right here is 1, right? So it means I'm going to have yn, I'm going to have yn to be equal to 1 times x squared ex plus, now I know that n combination 1 is equal to n, so I'm going to have n times 2x ex plus, I know that n combination 2 is this, so I'm going to have plus, okay, the plus is there, n minus 2 divided by 2, then times 2 e to the power x. So this is what I'm going to have, right? Let me try and simplify. Un is equal to x squared ex plus, when I simplify this, I'm going to have 2n x e to the power x plus, now this one, these 2 will cancel these 2, so I'm going to have n minus 2 e to the power x. So this is what I'm going to have, but there is something that I need to do. The question did not ask us to find the nth derivative. The question was telling us to find out what? The third derivative. So here is when n is equal to what? 3. So when n is equal to 3, let's put it inside. N is equal to 3. I'm going to have y3, which is the same as the one that we did here, y prime prime prime, right? So I'm going to have x squared ex plus, now I'll put the 3 here, so 3 times 2 is going to give us 6. So you're going to have 6 ex plus, now I'll put the 3 also here. When I put 3 here, I put 3 here, I'm going to have 3 times 3 minus 2, then it's supposed to be 3 minus 1. 3 minus 1 ex. So I'm going to have x squared ex plus 6 x ex plus 6 plus 6 ex, which is right here. So we can confirm that this is the same as the one that we did here. So x squared ex, and then 6x and then 6x here. So you see the idea of doing product rule, like doing this product rule, and then also using Leibniz theorem to do that. Somebody will be like, okay, this one is very simple. This one is not simple because we wanted to know the third term, right? What if the question is asking you to find the 20th derivative or the nth derivative? You cannot do it, right? For example, this one, when we got here, this is the n derivative, but look at this one. How are you going to find the n derivative? You do it with the n term. How are you going to see it, right? So that is the idea of using the Leibniz theorem. First, choose your u and your v. Write down your what? Your formula. Remember that n combination k can be written as this, and then choose your u in a such a way that you can differentiate it up to 0, or let me say the constant term. So this one, when you get to the constant term, there is no even need for you to bring u3 because everything follows is going to be 0. When you are done finding your 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 nth derivative, check the order. Is the question asking you to find the nth derivative? If yes, then fine. If no, this one was 3, so n was equal to 3, and we were able to find this one here. So in the next video, we are going to take examples to learn more on how to apply to various questions. Some questions we need to manipulate it before we can even apply the Leibniz theory. See you in the next video.